Now the question is, how do we charge objects? Now there are very different ways by which objects can be charged. One common way of charging objects is by friction. But an interesting thing to note here is that only insulators, that is, poor conductors, can be charged by rubbing by friction. Now, what happens during rubbing, and why is it that only insulators can be charged by rubbing? So, let's have a look at the process. Now, when we rub two objects, there is transfer of electrons taking place, right? So, let's take the example of this plastic comb. So, this is a plastic comb. And now plastic is a poor conductor of electricity, right? Or you can say an insulator. So when you rub this plastic comb on your hair, what happens? Due to rubbing, there is transfer of charge between hair and comb. So the electrons get transferred from the hair into the comb. So that is how the comb gets charged. Now the comb is charged. So now that comb gets charged, you bring it to these small bits of paper which are neutral. These bits of paper tend to get attracted towards the comb. So that is how we see that insulators can get charged by simple rubbing. Because during rubbing there is transfer of charges which is taking place, and due to transfer of charge, an object gets electrically charged. Because if the object is gaining extra electrons, it will become negatively charged, and if the object is losing out some electrons, it becomes positively charged. But in either of the cases, the object gets electrically charged. Now that's what we are going to discuss now. No charging by rubbing takes place in case of conductors. So here let's take an example of towel and a metal key. Key, it's made of metal, right? And metals are good conductors of electricity, so they allow charges to flow through them. Now take this key and rub it on the towel. Now in this case, when you take the key near the wall, you are taking the key near the wall, it doesn't stick to the wall, the key falls back. So there is no attraction between the key and the wall. Why? Because the key is not charged. Now key is not electrically charged. And why is it not charged? Because it's made up of metal, which is a good conductor. So what happens in case of conductor? In case of a good conductor, they allow easy passage of electricity through them. That is, they allow flow of charges through them. Now these good conductors will also have free mobile electrons. So these mobile electrons act as charge carriers. So good conductors, they allow flow of charges, or they allow flow of electricity through them. So as a result, what happens is, whatever charge comes into the metal, so that charge gets distributed all over the surface. But on the other hand, in case of insulators, whatever charge comes to the insulator, they stay at the same point. So the charges are static in case of insulator because they can't flow through the insulator. But in case of conductor, since the charges can flow, so the excess charge disappeared because they flow through the conductor. As a result, what happens? There is a movement in current which passes to earth through the conductor. So conductor basically acts as a path for the flow of charges. So all the charges flow through the conductor. So there is no excess charge now present on the conductor, and if there are no excess charge present, obviously then that object is not charged. That is what we learned, right? So if the object has to be positively charged, there has to be excess positive charge. If an object has to be negatively charged, there has to be some excess negative charge. But if the charges are just flowing through the conductor, that means there are no excess charges remaining on the conductor. Therefore, the conductor is not electrically charged then. So this is why we cannot charge conductors by rubbing. So this is something very important. This means that you cannot charge every object by rubbing. It's only the insulators which can be charged by rubbing. So let's look at one more example of charge transfer where charges are getting transferred from one object to another. Let's look at common example, that is rubbing between glass rod and silk cloth. So if you take a glass rod and silk cloth and rub them against each other, what's observed? It's observed that both of them get electrically charged. So the glass rod becomes positively charged. So positive charges are in the on the glass rod, and silk cloth becomes negatively charged. So what does this mean? The transfer of electrons took place from the glass rod to the silk cloth, right? So therefore the silk cloth acquired extra electrons, so it became negatively charged, and the rod lost electrons, therefore it became positively charged. Another example of rubbing a polythene, rub a polythene with a wool, that's another example. So there also you can see the transfer of electrons taking place between the two objects, and object gets electrically charged.